Welcome, and thank you for joining me today. My name is Brandon Minnick. I work as a developer advocate at Microsoft, and today we'll be talking about choosing the best mobile app framework. When making your first app, it can be difficult, it can be daunting to decide from all the different options that are available for us for our mobile app framework. And that makes choosing a mobile app framework really hard. It's not easy. There's a lot of information out there that can lead us down good paths and bad paths. And on top of that, there's a lot of considerations outside of the framework that impact our app as well, such as how much time do we have to market? What is our current development costs, maintenance costs? Do we have a team of engineers? Do we need to hire? What features do we need? How performant does our app to be? How performant does our app need to be? And what are the risks going with a third-party solution? So let's start today by talking about the first-party native apps. Now, these are the tools created by the creators of iOS and Android, who are Apple and Google. Apple makes iOS, and they also make the Xcode development toolkit that allows you to create native iOS apps in Objective-C and Swift. Google, who makes Android, has Android Studio that allows us to make native Android apps in Java and Kotlin. Now, the benefits of using first-party native apps is we get a native UI UX. So native UI, native user experience. Buttons look like iOS buttons on iOS. On Android, they look like Android buttons. We can swipe, the gestures, they're all baked in. We get that for free. But one downside is that the development speed is a little slower. And that's because we have to create the same app twice. Apple and Google use different programming language for their tool sets, and so we cannot reuse the same code between our apps. So even though our apps look similar, have the same features, we will have to rewrite those apps twice in two different code bases with two different engineers. So that increased our development costs, it increased our maintenance costs, and it slows down our time to market. But the benefit is, because we're using the first-party tools, whenever Apple releases a new feature or a new API, it'll be there in Xcode the same day. Whenever Google releases a new feature or new API, it'll be available to us in Android Studio that same day. So we never have to worry about falling behind, and we never have to worry about whether or not there will be support for these tool sets because they're made by the creators of the operating system. Another option is progressive web apps. Now, a progressive web app is essentially a website that is running locally on our device. With progressive web apps, we create the UI just like we would for a website. And there's many different technologies available, from Microsoft's Blazor, NativeScript, AngularJS, React to Iconic, that are tools that most web developers are already familiar with. Now, the benefit here is you might already have a team of web developers that created your website, and we can repurpose those skills for our mobile app. Now, one downside is the UI or the user experience. With progressive web apps, the UI will have to be bespoke. On iOS and Android, if we were using the native first-party toolkits like Xcode and Android Studio, they come with buttons, they come with navigation tools, and we essentially get those for free. With progressive web apps, we are recreating those tools, those UI elements, in our web frameworks. And so we essentially have to recreate that same look and feel that we would get for free if we were using a native app. One big improvement is the development speed. The code we write for our PWA will run on both iOS and Android, so we don't need to rewrite that code multiple times for the different platforms. And that also reduces our maintenance costs, but we've marked maintenance costs here as medium because if we ever need to refresh the UI, because that UI is bespoke, we'll have to rewrite that all ourselves. And so that is one risk, just like when Apple on iOS 7 made everything flat. Everything was skeuomorphic, and then everything became flat. Any app created with web technologies had to rewrite their UI, whereas if we were using the first-party frameworks, all we would have had to do is recompile our app to get that native look and feel. Performance is also a little bit slower than with a native app. Now, it's not that much slower. With a native app, we're talking about a 10 millisecond response time for a button click, and with a progressive web app, we're looking at about a 100 millisecond response time. Now, 100 milliseconds is still well below the threshold that a user would even notice, but if we're creating something that's fast-moving, that needed quick response times like a game, then maybe progressive web app wouldn't be the best choice in that scenario. This is also a fairly new technology. Now, one of the biggest downsides to PWAs is the feature access. PWAs cannot access every feature or every API available to us in a mobile app. Now, they do have the ability to access a lot of features like Bluetooth and geolocation, but they don't have access to a lot of other features like vibration, geofencing, and augmented reality. Now, one big benefit is I can install a PWA from the website. I can navigate to a website in my browser, tap Add to Home Screen, and this app will appear and run like a native mobile app. Now, typically, apps have to be downloaded from the App Store, but with PWAs, because they use web technologies, we can download it straight from the website. So this allows us to get new features to our users more quickly and ensuring that all of our users stay up to date. Now, the last category we'll discuss is the cross-platform native apps. These are frameworks that allow us to still create a totally native application. They give us access to every single iOS and Android API, but they allow us to write the app in the same code base so that we can share code between our iOS and our Android apps. Xamarin is Microsoft's cross-platform native solution that we build in Visual Studio using the programming languages of .NET, which are C# and F#. Our UI and our UX, totally native. We have fast development speeds because we are writing the app in one language, so we don't have to rewrite it like we would have to if we were using the first-party toolsets. And performance is just as high and just as fast as if we did create it in Xcode or Android Studio. Xamarin is also a mature technology. It's been around for over a decade, and it is feature complete, meaning every time Apple and Google release updates, Microsoft will release those same updates through Visual Studio. And it's also open source. React Native is Facebook's cross-platform native framework. Similar to Xamarin, Facebook also gives us access to every single iOS and Android API. So our UI and our UX is totally native. We have faster development speeds because, again, we only have to write the code once and it'll run on both iOS and Android. Our maintenance costs are low because we only need to fix the bug once in our code base. Performance is still high because these are native apps. We create them in JavaScript. And just like Xamarin, React Native is also a mature language or mature framework that is open source and feature complete, as anytime Apple and Google come out with updates, Facebook will also release updates via NPM. And the last tool we'll discuss is Flutter. Flutter is Google's cross-platform native solution that is pretty new. Now, Flutter is different from Xamarin and React Native in one way, and that is Flutter does not use the native UI and UX APIs provided by Apple and Google. Flutter uses a bespoke method to draw their own UI on the screen. Now, there is a benefit to that because it is faster, but one downside is that whenever iOS and Android come out with new UI updates, Flutter will also have to come out with their new libraries to mimic those updates as well. It is feature complete. They also release updates via NPM. Very fast, high performance apps, and they are all created in Dart. Now, Dart is a new programming language created by Google. Not that many developers are already familiar with it, but it has many similarities to Java and C#, and a lot of those developers will take to Dart very quickly. Flutter is new. It was just released within the last year or two, and it is also open source. Now let's look at a couple scenarios that our company may be in to help us choose which app would be best. In this scenario, we're creating a simple mobile app. Our company has an existing website created in AngularJS. We have an engineering team of web developers, and the app we're creating doesn't require a lot of features. In this scenario, it makes a lot of sense to create a PWA for our mobile app, a progressive web app. And specifically, because we have existing developers familiar with AngularJS, we can use that for our PWA. In this scenario, we want to create an augmented reality app. We have venture capital funding, and we have a leadership team who are weary of third-party frameworks. So in this scenario, it makes a lot of sense to use the native toolkits. We don't mind the extra development cost of having one team work on our iOS app and another team working on our Android app, because we don't want to take the risk of using the third-party frameworks. In conclusion, which mobile app framework is best? It's the one that's best for your team. Every team is going to have different scenarios. Every team is going to have different capabilities. And as long as we understand the trade-offs between native first-party and PWA and cross-platform native, we can ensure that we choose the best mobile framework for our team. Thank you.